Students, this is MJ. Today we will see a fresh chapter, that is chapter number 8, operators and expressions. One thing I wanted to tell you, if you are suppose if you are referring to a Smita or a book, the chapter number changes. New book yet to come, right? Syllabus is changed and chapter number also changes, right? Don't worry, the topics will be the same. Chapter number will be different, right? So chapter number 8 we will discuss operators and expressions, right? This comes in to computational thinking and programming, right? So introduction. What is an operator? Operators are tokens that trigger some computation when applied to a variable. So operator is an action which will be performed whenever you use them in program, right? So what is unary operator? Unary operators are those operators that act upon single operand, right? Say unary plus, unary minus, so bitwise complement, logical negation, these are all various types of unary operators, right? So what is binary operator? The binary operators requires two operands to act upon, right? So to operate upon or to act upon, say for example plus you are using x plus y, two operands are required. Here plus is an operator, x plus y, x and y are called as operands, right? So x minus y, x into y, x divided by y. So wherein you require two operands, so that requires two operands, that is called as binary operator. Unary means you can apply for a single operand, minus x plus x into x you never say, divided by x you never say. Whenever you say divided by, then you say y divided by x. So that's why these are all binary operators, these are all unary operators, right? So next is your bitwise operators and bitwise exclusive or, bitwise or. Then you are having some shift operators, left shift and right shift operators, right? So we'll see practically how these operators be used in the program. You have relational operators, less than, greater than, equal to, less than, equal to, not equal to. Like this you are going to write in the Python program. These are all the various symbols you use in Python, right? So this needs to be kept in your mind, right? Python, right? So Python language, greater than, less than, equal to, greater than, equal to. All these operators you will use like this, logical and simply and you write, right? So binary operators example, say for example I am going to say equal to 10 b equal to 5, result equal to a plus b result equal to 15, right? A minus b, a into b, a divided by a mod b. A mod b will give you modulus. This is a modulus operator which gives a remainder part, right? So this you see this 10 divided by 2 will give remainder 0, right? If I say 11a equal to 11, so it will give you 1, right? So remainder part. So modulus operator always gives a remainder part. So this is what you are going to use exponent a star b will give you, a star b will give you 10 raised to 5, right? This is then a double floor, double slash b will give you floor division, right? So these are all you will execute and check it. Just I will open the Python, right? Then I will now, if you want to write a program, you can write a program. If you want to type at the shell means one by one command you have to execute. So I will write a program better. Def operators example. Say example, some operators. So I'll say A equal to input, enter the number. Okay. What I do is I'll convert it into integer type, and then I'll use this. Okay, B equal to, let's say, input, so now what I do is use addition, subtraction, multiplication, division, floor division, and what modulus. These are various parameters we'll see. So I'll say add equal to a plus b, very simple. Multiply remainder part R, you get remainder part, so I am using R A mod B. Right? So yes, you see this much we can see first. And add, right? Subtraction. Yes, you increase sub, then I'll have modulus operator. So here I have not defined what subtraction. This will be so that's why I write a driver code. So driver code to call this function. So I'll call this function operators underscore what's the file name? E4. You can run it shell also. Enter the first number, I say 60, I say odd number I will use so that I will give small number 7, I will give 2 so that you can manipulate. R is not defined, very good. R underscore I have used. You see, this is taking so all you have to take it off. You should not be taking this type of 7. Okay, this is what you are getting. See, addition of two numbers 7 plus 2 is 9, and subtraction is 7 plus 2 5, multiplication 7 to 14, division is 7 divided by 2 3.5, modulus is 1. That is, if you say 7 divided by 2, 1 will be the remainder. The remainder part will be, right? So this is how you are. So if I say remainder A mod n, if I say what will be the values? I enter the same number. You can enter different number also. Let me enter the same number. See, modulus is 7. Why modulus is 7? Because A mod 10, 7 mod 10, 7 mod 10 will give use 7 remainder only. You are not dividing it with taking a point, 0 adding, no, not, no, only integer numbers. So 7 is the remainder you are putting it. So that's how you know you want to work on these numbers. Fine. So see the next operators. So we'll see the next topic, that is we have seen addition, subtraction, multiplication, division and mod, right? So next is exponential flow division, right? These two, exponential flow division, execute and check it. Say for example, I'll open the shell and execute. Supposing that if you want to find out 2 raised to power 3, so I say it's equal to 2 double star 3, okay, x 8. So this is what in exponential form can be presented. So the same thing I wanted to do with e to the power b. How I write, say for example, power expression, I say b a to the power b can be written like this. Same I am printing statement. I'm getting b. So this is what b equal to. Now you run this program and check it. First you say this one and you run this one. You say 9 and I say 5. 9 raised to 5 is 590. So you use a small number so that you can calculate yourself. Output is say 2, let's say 2 raised to 4. So 2 raised to 4 is 16, so that's all. So keep fine, right? So next is your floor division. Floor division is very easy. If you are having say floor division, if I say a double slash b will give you floor division. So here I will mention comma f equal to floor division f. Okay. So before having this code, I will tell you Google potential. Say I say x equal to 10, y equal to 3. So if I say result x double slash y, okay, and you see r, you get 3. So you should get 3 point something. If I say r1 equal to x divided by y, then I get r1 is 3. So r1 you will get 3.33. So 3.33 is truncated. If you see, floor division will give the lowest number. That is what the lowest number is 3, right? Seal is 4, right? Floor is 3, seal is 4 because you are having 3.3. So this is all about floor division. Just will run this code and check it out. So first number is say 16 and I'll say 3. Okay. Floor division is 5 point something. You should get floor division, right? This is how you are going to execute floor division. So all these things you have to execute and you have to check it. Bitwise operators examples we'll discuss in the next class. Thank you very much for your kind listening. Execute all these and check it. Any problem comes, please project it to me. I'll solve it your problems. Thank you very much, Marcus. Take care. Stay safe.